So in this video, I'm going to start topic 7, which is called Newton's first law of motion. So we're back on orange page 21, student notes, and we had done the little first part that said, what is inertia? And now we're starting on the section that is titled Newton's first law of motion. So this law is also known as the law of inertia. And obviously, now that we've talked about what inertia is, that makes sense. So you want to know it by both names. So Newton's first law is known as the law of inertia. And it's basically talking about to cause a change in motion, the net force acting on an object cannot be zero. So the statement that I like to use at this point in the classroom that you need to memorize is a body at rest remains at rest, and a body in motion remains in motion in a straight line at a constant speed unless acted upon by an unbalanced force. So you're going to want to memorize this statement pretty much word for word with all that phrases in there. So you probably should mark this. That's why it's highlighted in yellow on your note sheet for you to start practicing that. So I want to share with you a very short video about this.
Did you know that physics is about how things move and why things move? It was Isaac Newton who discovered the 3 laws of motion. He was a scientist who lived from 1642 to 1727. Let's first learn about the first law of motion. It is also called the law of inertia. It states objects will remain at rest or in uniform motion in a straight line unless acted upon by an external unbalanced force. To understand Newton's first law completely, we need to learn about inertia first. See, this is a very large sofa. What's special about it? It's stable. It is not moving. Now go ahead and try to move it. Oh, you can't. It's not willing to move. You can't move it as it is very large. Now try to move this small stone. Good. You can move it a little bit, but you had to put in a lot of effort. It was also like it didn't want to move from its original position. Even the smaller things don't want to change their positions. They don't want to move. Even a small stone takes some effort to move. This is the first rule of physics. Things like to stay where they are. No object in this universe would start moving unless some external effort is put on it. It's like all things in the world are lazy. Now the question is, if things are lazy and they don't want to move, then how does the movement happen? The answer is that there are so many things in the universe which push and pull other things and force them to shift their positions, like you forced the small stone to move. But as we said earlier, that things are lazy. They would try and stop their movement as soon as the effort was removed. Well, you'll be wrong if you think like that. You'd find it very strange to accept that when a small stone was still, it wanted to stay still. And once you'd put it in motion after putting some effort, it would like to keep on moving. In reality, it would keep on moving forever and ever. But somehow it stops. But it stops not because it wants to stop. It stops moving because things in its path force it to stop. It may be due to air, or if it bumps into a tree or rough surface on the ground. But suppose there were no tree in its way, or there was no roughness on the surface, and also imagine that it does not have poles or trees in its way. The stone would never stop. It would keep on moving. It happens in outer space, where there's no air or roughness. If you kick a small stone, it'd keep on moving and would never stop. So how can we say that things are lazy? See, the small stone wanted to move forever, but it was stopped by the resistance of air, trees, or roughness of surface. It's like you moving on a slippery road. You'd keep on moving unless there was some effort put in to stop you. The same is true with the small stone in outer space. It would keep moving, as nothing came in its way. It also doesn't want to stop, as it is too lazy to do that. So now we can change the first rule of physics. Things want to stay in the position they are, to things want to keep doing what they're already doing. If things are at rest, they want to stay at rest. And if things are moving, they want to keep moving. In other words, things are lazy. So there's a lot of laziness in the universe. Physicists have a special name for this laziness. It is known as inertia. So now you understand Newton's first law of motion. Can you write it? Well, you are very much right.
So that is a nice video that talks about Newton's first law of motion. So let's keep on moving through some of our notes here. So I have here Newton's first law. An object at rest tends to stay at rest unless acted upon by an unbalanced force. So that's part of it. So sitting on a couch, ball sitting on the ground, those are all good examples. The other part of the law of inertia says that an object in motion tends to stay in motion with the same speed and direction until acted upon by an unbalanced force. So after a ball is kicked, it's had an unbalanced force acted upon it, and so now it changes its direction or its speed or both. So a nice pictorial of a soccer ball here. An object at rest remains at rest unless acted upon by an unbalanced force. And an object in motion will continue with constant speed and direction unless acted upon by an unbalanced force. So when the net force is 0, you can see like this motorcycle here, even though the engine is obviously revving and you can see all the smoke coming out the exhaust, the motorcycle can't go anywhere because the force that's being applied by the engine to try to cause that motorcycle to move forward is being counteracted by the force of the cement block stopping it. So Newton's first law of motion has several important implications. So first one is that an external force is required to change the speed and or direction of an object. It has to be external to whatever you're trying to move or stop. For an object to change velocity, including changing from being at rest, the net force must be greater than 0 in one direction. Objects at rest remain at rest unless acted upon by an external net force that's greater than 0. And moving objects continue to move in a straight line at a constant speed unless they're acted upon by a net external force. So there's a lot of things that are wrapped up into this one very simple statement of Newton's first law of motion. So a couple of examples for applications. So the first one is when a car slows down really quickly, the people in the car tend to continue moving forward. And if you were not restrained at all and you were just sitting in the car, you possibly would crash through the windshield and fly out of the car because you were moving with the car tried to stop, but since you weren't attached to the car, you are going to keep moving forward. When you have a seatbelt on, you actually are kind of like stuck or adhered to the car, and it prevents you from flying forward and going out the windshield. So this is a safety measure, which is using Newton's first law of motion. So an airbag acts in a very similar fashion to stop the person from hitting their head on the dashboard or steering wheel, because both of these work to reduce the inertia that it's experienced by the passengers and prevent you from continuing in motion and heading out the windshield. So what I'm going to ask you to do for follow-up work here is to read an article that's in your packet on page 24 and 25 and answer a couple questions. It's called Forces and Concussions in Sports, and I will go over the answers in the next video.